This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts. In today's episode, you will learn how to make a smart swimming pool monitoring system using Arduino boards, a pair of SX1278 LoRa Transceiver modules, MPU 6050 accelerometer and Gyroscope Module, and a 5-volt buzzer. The objective behind designing this swimming pool monitoring system is actually based on my commitment that during the ongoing summer and during the summers coming ahead, we do not have to let any child drown. So you are requested, guys, to share this video as much as possible so that more and more people come to know about this useful system. According to the US Consumer Product Safety Commission, 390 deaths a year on average are attributed to drowning in a swimming pool. The majority of the deaths occur during the months of June, July and August, mostly in the backyard pools. If this is the situation in a country like the US, where everything is so systematic, just imagine for yourself what will be the kids' death rates due to drowning incidents throughout the world. As an engineer, I consider it my duty to devise a kind of a system which may prove helpful in the protection of any precious life. So I will go ahead and definitely work on the accomplishment of this cherished obligation. A lot of people, mostly the parents, usually inquire about how to save a child from drowning and how to keep their kids safe at the pool. Well, you have two options for this. Number one, as a precaution, you can build a sort of a barricade around the swimming pool to keep the kids away, and number two, you can make a smart swimming pool monitoring system to alert the parents when there is any kind of activity in the water. If you select option number one, then believe me, kids are very sharp and clever these days. They will definitely find out some sort of a mechanism to reach out to the pool. However, if you select option number two, then rest assured, even the slightest activity in the water will trigger the system, and parents will abruptly come to know that somebody is venturing in the water, and then they can go around and check the scenario by themselves. Now let me tell you a bit about this swimming pool monitoring system. At the time of designing this system, I studied water ripples. My goal was that from whichever direction ripples or waves come, my design system should be so sensitive that it can detect these ripples. I kept thinking about different types of sensors for a significant period of time, and then all of a sudden the MPU 6050 module came into my mind. The MPU 6050 module is best for the project because with the help of the MPU 6050 module, we can monitor 3 axes, x-axis, y-axis and z-axis simultaneously. So I made this prototype model. You can clearly see that I have connected MPU 6050 and LoRa SX1278 modules with Arduino. This particular side is the transmitter and it will be placed on the swimming pool side. And this side is the receiver which will be installed somewhere inside the house. A buzzer is attached to it. As soon as ripples are generated in water, this buzzer will automatically turn on. Let us kick off our practical demonstration so that you can see how beneficial this swimming pool monitoring system can be. Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate and they will instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you are able to comment, markup, cross-probe, inspect and more. Comments are attached directly to the project, making them viewable within Altium Designer as well as through the browser interface. Design, share and manufacture all in the same space with nothing extra to install or configure. Connect to the platform directly from Altium Designer without changing how you already design electronics. Altium 365 requires no additional licenses and comes included with your subscription plan. Get real-time component insights as you design with Octopart built into Altium 365. Octopart is the fastest search engine for electronic parts and gives you the most up-to-date part data like specs, data sheets, CAD models, and how much the part costs at different amounts, etc. right in the design environment, so you can focus on your designs. Links to the Altium Designer, Altium 365 and Octopart are given in the description. First, I'm going to do some basic testing, and thereafter I will practically test it in water. So you can see that I have powered up both the transmitter as well as receiver's side. I have done its programming in such a way that when MPU 6050 is on an absolutely flat water surface, it does not send any trigger message to the receiver side. However, if the slightest change occurs in any of its axes, its system triggers and buzzer on the receiver's side turns on. It has the capacity to detect even the smallest of vibrations. So if you observe during the testing that this system is very sensitive, then you can modify its threshold values in the programming, which later I will explain. Now we move on and practically test this project in water. You can see that there is no ripple on the water surface, and that's why the buzzer on the receiver side remains off. So let us move forward and produce some ripples in the water, and then we see whether the system detects these ripples or not. It has been working amazingly, even better than my imagination. So the prototype model has turned out to be a success. If you want to implement this swimming pool monitoring system in reality, you can reduce the transmitter size by designing a small PCB. You can use Arduino Pro Mini, which will render it into a significantly small size, and as such you will be able to power up this system even through a small 3.7 volt LiPo battery. I'm sure by now you might have got an idea of how does this system work. So without any further delay, let's get started.
Access granted.
The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. This is the circuit diagram of the transmitter side. The VCC of the SX1278 LoRa module is connected with 3.3 volt of the Arduino. The MISO pin of the LoRa module is connected with the Arduino pin 12. The MOSI pin is connected with pin 11. The SCK pin of the LoRa module is connected with pin 13. The NSS pin is connected with the Arduino's pin 10, and the ground pin of the LoRa module is connected with the Arduino's ground. The VCC and ground pins of the MPU 6050 module are connected with the Arduino's 3.3 volt and ground pins. while the SCL and SDA pins of the MPU 6050 module are connected with the A5 and A4 pins of the Arduino. A5 is the SCL and A4 is the SDA. On the left side is the regulated 5V power supply based on the LM7805 voltage regulator. On the receiver side, the connections of the 5V regulated power supply and SX1278 LoRa Transceiver module remains exactly the same. A 5V buzzer is connected with the Arduino pin 3. A 2N2222 NPN transistor is used to control the buzzer. The 10 kilo ohm resistor and 2N2222 NPN transistor make the driver circuit. Now let's take a look at the transmitter and receiver side programming. I have these two programs. One is written for the transmitter side and the other one is written for the receiver side. Anyway, before you start the programming, first of all make sure you download all the necessary libraries from our website electronicclinic.com. I will provide a link in the description. Let's first start with the transmitter side programming. Maximum of the code I have already explained in my previous tutorials. The purpose of this code is to read the x-axis, y-axis and z-axis values and then compare these values with the predefined values. So if the value on any axis is less than or greater than the predefined value, then a value of 1 is sent to the receiver side. Otherwise, a value of 0 is sent, which means there is no activity in the water. Now let's take a look at the receiver side programming. The purpose of this program is to check if a value of 1 or 0 is received. If a value of 1 is received, then turn on and turn off the buzzer a few times, and then finally we make the trigger signal equals to 0. GetValue function is a user-defined function which I have been using in all those projects where I needed to split a string message. So the purpose of this function is to split any string message using any character as the delimiter. In my case, I'm using comma as the delimiter. So that's all about the programming. You can download these codes from our website electronicclinic.com. I will provide a link in the description. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.